What does that $sign mean?
User, not a root.
I'm not signed in as a privileged user account. So the command we want to run is so we're going to go SU space hyphen. That is the switch user command. Guys, we've done some of this stuff to on chapter 1 already. You know, just last time we met.
If you don't put anything, it means root anyway?
Yes, it assumes root. If you don't specify a user account, it assumes root. What's the command to see who I'm signed in as? Who am I? Guys, I'm going to try to stick to the book. I'm right now on chapter 2, accessing the command line. Some of that stuff we've already done. Date command shows me the date. After command, you have things that you could do. You can supply additional stuff after the command. Those are sometimes called switches, parameters, things like that. If you want to see them, what you could do, how do we get help for a command? Date dash dash help. Sometimes it'll be date dash help. You know, dash H. If it's an old school command, it'll be dash H. If it's a newer command, it'll be dash dash help. But what's wrong with this with this command? What did it do? It scrolled off my screen. So what I can do is do a pipe character. This is above the enter key. Then I can type more. So basically, the more command takes your output and displays one screen at a time. So I'm going to take the data from the date command, my output, and make it the input for the more command. So I'm just redirecting my output to become the input for the next command. Okay, I'm going to try to, and what it does is that at that point, it'll show me one page at a time. So these are all the additional things I can run with the date command. There's a lot of stuff you can do with it. If I hit the enter key for more, it brings me down one line at a time. If I hit the space bar, it will bring me down one page at a time. The problem with more is you can't go back up, so you have to be careful. Good, haven't seen you in a while. What was your name? Oh, there you are. Okay. Hey, listen, was there someone sitting here last time? Okay, try to boot up here or here. If you see this on the screen, on the blue screen, you're going to have to find another location. So basically, these are the additional things that you can do with that command. Guys, I'm not really worried about this command. I'm just trying to show you how you get additional information for any command. So in this particular command, we can do date. And the format of this command is kind of unusual. %R. And I can just look at the time. If I want to look at just the date, I can do plus $X. And there it just shows me just the date or just the time. And if I don't put any parameters, it shows it to me in that format. So you can define how you want to format the actual date. This is CTS1111C, someone said there. So try another C. Okay.
So log in Windows first, right?
Yeah.
Create the.
Okay, yeah, it's going to be a while. Okay, so I'm going to do the list command. That shows me all of my files in my current directory. What's the difference between this and this command? We talked a little bit about this one. Not only do I see the files, I also see additional things. Permissions, number of copies of the file, user owner, group owner, the size of the file, the date it was last accessed. So if I do a list long, it'll list everything in that file. These are permissions. I have 11 items there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a dot. There's a bunch of different things going on, but that first line tells me the file type. So this right here tells me the file type. The next 3 characters tells me permissions for a user. The next 3 characters tell me permissions for a group. The next 3 characters tells me the permissions for everyone else. Then the last one says if there's more permissions that I have to look elsewhere. I'm only looking at this first line right now. So basically, if that is a dash, it's a file. If it is a D, it's a directory. If it is P, it's a pipe device. I don't want to go into what a pipe device is, but it's not a normal file. I have C as a character device. That would be like a driver for a modem or a serial card or a network card. One character at a time is being sent. If that first character is a B, it's a block device, which means it's a device driver for like a parallel printer if you still have one of those. L is for a link, kind of like a shortcut. There might be more that I can't remember. So right now, everything we're seeing is a file. So if I do a list in another directory, list long in another directory, I can see that this is a directory, this is a file, this is a directory, you know. So just by doing a list long, I can see whether something is a file or a directory. you can't always look at the color codes, because you might not have color codes. If you're connecting remotely, you're not going to have the color codes. These extensions here, we're very used to extensions in Windows, but they have no meaning in Linux. I don't need an extension in Linux. That's just for me as a human to look at that and say, oh, that's a script, or that's a configuration file. This directory has a lot of those, but most of the time we don't have those. So basically, it's just going to tell me that these are files. Now, I need to know what type of file. Is it a text file? Is it a compiled file? Is it a binary file? How do we know what type of file it is? Well, that's where the file command comes in. So if I type in file anaconda.ks.cfg, I can see it's just a regular text file. Give me one second. Guys, you could have a bunch of different copies of a program installed in multiple different locations. So when you run the command, you don't know which one you're going to run. So there's a command that tells you which command you're going to run if you type a command. So if I type which IP, it'll tell me which IP command I'll actually run. So it also tells me the location of that command. So in this particular case, if I type in command IP, that's what I'll execute. And I'll explain here in a little bit why you have multiple copies of files. So I'm going to type file user sbin IP. So this is a text file, this anaconda.ks, and this is a compiled file. Just because a file is compiled doesn't mean that it's executed. Remember when I was talking about those permissions? What makes it executable has nothing to do with what type of file it is. It's determined by the execution data terminal. We'll go into that later in the course. So this is a compiled file, this is a text file. So that first character will tell you file, directory, pipe device, block device, things like that. And then the file command will tell you what type of file it is. So we determined that this is a text file. And this is a compile file. So if I cat anaconda, guys, what am I typing here? Cat ANA. What character? What key am I pressing on my keyboard to complete it? Press the tab key to complete. The cat command stands for concatenate. It allows you to join multiple files and display them on your screen at one time. It also, if you only have one file, it will just display the contents of that file. So all I'm doing is just looking at the contents of the file with the cat command. If I had one file, it'll show me one file. If I did it with two file names, it will show me two file names. So the cat command is actually just displaying the content of a file. Now I can display the content of a ASCII file with a cat command, because that's what it does. It shows me the text in that file. But what if I did this other file, user sbin IP? I can't display a binary file, like a program that's been compiled. If I try to run the cat command, it's not really going to show that file at all. So you can cat an ASCII file, you can't cat a binary file. It won't allow you to do it. There's other commands we can run to see some stuff, but for right now, just be aware. If the file is ASCII, you can display it with cat. If the file is not ASCII, you can't display it. Okay, I have these two files. I have this grubby and this prep.sh. I can do cat, grubby, then prep, and look at both of those files at one time. So in this particular case, I'm joining two files together and displaying them on the command line. Here's the end of one file, here's the other file. So that's what concatenate really is supposed to do, is join two files together. But 9 times out of 10, what we end up doing is just looking at one file. That cat command is kind of your go-to command. You know, when you want to look at a file, that's what you probably go to. Probably the most used Linux command that there is.
So does it show you like the file info, like slides wise and
List-long, that shows it to you. But this number isn't really in a nice readable human form. So if you put list H for human, it'll show it to you in some nice readable form. So this is 93 bytes, this is 1.4K, and it will put it in gigabytes. By default, everything is in bytes. So if you don't want to calculate bytes to kilobytes or bytes to gigabytes or something like that, then that will help it a little bit. So no, cat will only show you the contents of the file. It will not show you the other information about the file, just the content. Okay, guys, I want to ask you something else. Let me see. I'm going to create a. You see this right here? It's in my downloads folder. That script. It's a text file. That's all it is. What is the command in Windows to do the same thing as cat? I want to just look at a file, the contents of a file on a command line. I'm going to go to the downloads folder, and I'm going to do a dir and look at the file. Guys, has anyone heard of this command before? Look, type, tab complete works in Windows 2. All that does, the cat command is the same as the type command in Windows. Windows will just display a text file with the type command. In Linux, it's called cat. So we have very similar things in Windows. I'm going to exit out of here and go back to Linux. I have a directory called var log, list var log, and I have a bunch of files in there and directories. If I do a list log, I can see I have a bunch of files, some directories. Right here, this file right here is all my logs. Every time an event happens, those are my logs. After a while, if it gets full, it backs it up and creates a new log file. So this is kind of, if something's going wrong in your system, you automatically want to cat this file. But this file could be 4,000 or 5,000 lines long. So you have to look at it in pages. So I'm going to look at this file right here, an old one. So I want a nice large file. So I'm going to look at the contents of that file. So I'm going to cat. The directory that it's in is var log messages. And I'm just going to stick with this file. I know everyone will have this file. That directory var log has all kind of information about your running system. Can I hit enter? Okay. So it just displayed a whole bunch of files, a whole bunch of data. In fact, if I pipe, I can do word count, lines. This is only 23 lines. But guys, this could be a lot bigger. Basically, word count will count how many lines are in a file. So I can cat a file, pipe it to word count, and look for lines. So if I want to break that up so it doesn't just scroll past my screen, I can put the more command, which we talked about. If I hit the enter key, it goes down one line at a time. If I hit the space bar, it goes down one page at a time. If I want to leave it, to get out of the command altogether, hit Q to quit. Let's say you found what you want to get out of the command altogether, just hit Q to quit. I could also do this. And get the same result. The problem with the more command is it doesn't allow you to go backwards. So cat var log messages, pipe it to less. You know that phrase, less does more? Well, that's what they do. That's what they did in this case. They created another command called less that does more than the more command. Not only will it allow you to go down and view a file, it will also allow you to go back up. Okay, they always do this. Here, I'll give you another example. The people who program Linux has too much time on the commands. Cat command displays a file. What if you want to display that file backwards? What command would you use? Cat spelled backwards. So cat spelled backwards will display the top of the bottom of the file first and go toward the top. So they're always doing things like that. So the cat command displays a file backwards because you're just spelling cat backwards. Okay, so the less command does more than the more command. So if I pipe into less, I could also go back up with my arrow keys. Or go down with my arrow keys.
What if you type less backwards?
Nothing. It's not a command. Okay? So, less does a little bit more. And again, I could do it like this. I'm giving you to that command next, Jessica. Same thing. Enter key, one line at a time, space, one page at a time. Or I can hit the up arrows and go back.
Is there a certain shortcut you can use to go directly back to the bottom if it's a lot of lines and you don't want to wait instead of hitting space bar for 15,000 lines?
Hold on one second.
Like the line?
Wait, there might be.
Control C and stuff didn't work.
Not in this, in other files. But look, if this command, I know it's only 23 lines, so I'm going to go to line 1000. That'll take me to the end. Just type in a line number, it'll take you to that line.
Because mine does have 15,000, so I would have to do 15,000 or 16,000.
20,000, some huge number.
Just add it. It's right there.
Yeah. Or run another command and only look at the bottom. We'll get there. Okay, so guys, let's do our first break. I'm going to pause the video. I'm not going to do this all the time. Oh yeah, space does work. The escape does work. Okay, I'm still waiting for someone to give out. Okay, so guys, the cat command displays a file. The more command displays a file one line at a time or one page at a time. The less command does the same thing but allows you to go backwards or forwards. I'm going to write down these commands that we've done so far. We looked at the date command mainly to see how to get help. We did the list command, we did the L option, we did the H option. Guys, what was A? Remember we did A last time? What does A do? Show hidden files. Any file or folder that has a dot at the beginning of the name is a hidden file. We looked at the cat command, displays files, head command, less, not the head. The more command, the less command. I want to show you something else. I started this and might as well finish it. So if we do cat Etsy password, it's another file. Pipe it to WC. It shows you the lines, the words, and characters. So this has 46 lines, 109 words, and 2,573 characters. I can do just lines, or just words, or just characters. So WC is word count. Now, if I look at some of these files, like these log files, most of the good data that I want to look at is recent. So I just want to look at the very end of the file. So I can type in cat var log messages and then tail. And that will show me only the last 10 lines of the file. You know, if you're looking for something that just happened, a program crashed or something, you want to look at the log file, you can do just the last 10 lines. Guys, I always do it like this, just because I'm so used to piping and catting, but you can do this as well. Var log messages. And that will work as well. But let's say you only want to look at the last 2 lines. I could do that. That'll show me the last 2 lines. I could also put a space between the N and the 2. That will work as well. Or I could look at the last 20 lines. So tail will show me the last, by default, 10 lines or you specify a number, it'll show you that many lines. A dog has a tail. What's on the other end of a dog?
Nose.
Bigger.
Head.
That will show me the first 10 lines of a file. Or if I specify, guys, how am I getting to this command quickly? I'm hitting the up arrow. Or I can see the first 5 lines if I specify. And again, that there can be a space between the end and that 5. Not all commands will allow you to get away without a space, head and tail for one of them. You don't have to put a space between that.
So anything that goes after the pipe, and theoretically, you're saying you can go before the command, or before the files of the shell.
Right, when you're editing, like when you're manipulating a file somehow, you know, if you're trying to manipulate a file, that's you can use the cat command. Like cat Etsy password. This file right here is my user account database. We won't get into this in more detail, but that's a user account name. That tells me the password is encrypted in another file, the user ID, the group ID, the friendly name. Like if my user account name is B Ferris, my friendly name would be Brian Ferris. My home directory in my command interpreter. By default, we're using bash. Right, guys, what we're using to interpret these commands is called bash. What is, back in the day when they first invented Unix, they had something called shell. The keyboard didn't exist like it does now. Everything to the right of the number, all this wasn't there. So the shell command, the shell interpreter couldn't understand all those keys. So if you wanted to use the up key, you had to press D. If you want to go left, you press S and things like that. Well, with the new keyboards and everything, we wanted to take advantage of it, so someone came up with born again shell. We call it bash. So that's the command interpreter that we use. The only Unix derivative that uses bash by default is Apple with their Mac, but most of them still use shell. So if you go in a Linux box and you press the left arrow button, if you go to a Unix box and press the left arrow button using shell, nothing's going to happen because it doesn't understand that key. So basically I'm looking at a file and I can manipulate this file. Again, our goal is to be as lazy as possible. This is information overload. I don't want to see all that information. I could, can you see that this is just a colon delimited file? Multiple columns. I only want to see the first and the third column. So I could do things like filter out data. Cut field 1, 2. 1, 3. Cut. And the delimiter is a colon. I don't know what I'm doing wrong. I'm not doing anything wrong. I don't know why it's not working. Cut. Field.
Delimiter. I'm not sure why this command's not working. It's the right command. Oh, there's why. Because I didn't put the delimiter first.
Okay, so guys, when I say manipulating a file, here's a piece of example. So I'm patting the file, it's going to display the entire file. Then I want to cut out only columns 1 and 3. The delimiter is that colon, and fields 1, 3 is the first and third column. So that's what I mean by manipulating a file. I can take this and display only portions of the file. There's other commands we can use called grep to grep out lines. We can use cut to filter out. We can use grep to filter out lines. We can use cut to filter out columns. So that's what I mean by manipulating a file.
We'll get into that in later stuff, but this makes it a lot easier not to get information overload by looking only at the data that you want to look at. Guys, type this command right here. I just want to show you some stuff to jump around. Control A jumps me to the beginning of the line. Control E takes me to the end of the line. I'm on that /. If I hit Control U, it deletes everything before my cursor. If I'm on the pipe character and I hit Control K, it deletes everything to the right of my cursor. I'm going to do this again. Cat. If I do Control L, it goes, Control left arrow rather, it'll take me one word at a time going backwards. The right arrow will take me one word to the right. I'm going to erase everything. Control R will allow me to search for commands. Search for commands that I've already ran. So if I want to look at CA, if I just type CA, it's going to show me commands that start with CA.
So you type Control R, start typing the command, and it will show you the command from your history.
Okay. I can also look at history. So if I want to run this command again, if I want to run this line again, I could type bang 83. And that will run that command. I don't ever use the Control R. I can do this as well. Bang HED. HEAD. That will run the last command that started with the word head. If you look at my history, the last time I ran this command was here. So there it is again. Guys, this one isn't in the book, but I use it quite a bit.
many times have you typed a command and you type 2 characters backwards? If you go to the last character
and hit Control T, it'll flip them.
It's like autocorrect.
well, it's not autocorrect, it'll just flip those last 2 characters.
Oh.
Which
Only the
stands for-
last 2 characters?
Right. Which stands for translate. I don't know why it's called translate, but
Last 2 characters
Transpose, that's it.
for the cursor.
Where my cursor's at. So like right now, I'm on the A key. If I hit Control T, it'll flip those. If I go back, hit it again, it'll flip them again. I'm just okay, guys, I'm moving to chapter 3. Guys, the book is weird. It kind of like saves your location. So if I jump to chapter 3, it takes me to the last place I was in chapter 3. So I have to manually go back to each page. I can't like click on the link and go to the beginning of chapter 3. Okay, I'm on chapter 3. Guys, I can't put this on YouTube. Sorry. I can't show you the book because if I record and put it on YouTube, it's proprietary textbook. If you were to go to Red Hat and register for the course directly through Red Hat, it would charge you $3,000 for that textbook. Because we're a Red Hat Academy, they give it to you for free. You also get a 25% discount if you decide to take the Red Hat test. So I can't show you the textbook. You have access to it. I'm on lesson 1 of chapter 3. I want to go over the file system. Just so you know where things are in the directory listing. I'm going to go and look here just to see a graphic location. I went to other locations and I clicked this computer. What's that directory called? Root. All directories are under there. In Windows, when you have a different, I'm sorry?
No, I was just, remember we had a conversation last time?
Oh, that's fine, I'm recording, you're good. So, that is the top of the file system, we call it root. In Windows, if you had a different partition, it would be under the D drive, or the E drive, or the F drive. You don't have that in Linux or Unix. You can't see it right now, but I'm on one directory, but if I'm in one partition, but if I go into boot, that would be an entirely different partition. So by just looking at this hierarchy, you don't know how many different partitions you're looking at. I could go into the home directory, and that could take me to a different server altogether. So it's transparent to the user when they go into this directory, whether if they're on the same partition or even a file share. So you don't really know. But I'm going to try to go over what the majority of these directories are. It's kind of important.
So there's no way we can know if it's a partition or
Can't find out?
There's ways you can find out to run commands, but by default, you won't know. It's not, I can tell you right now that this is a different partition. I know from experience. So we call this root. That's the top of our user hierarchy, our file hierarchy. Who am I signed in as? Oh, remember, we asked you it as root.
Yeah.
So I'm signed in as root 2. Don't confuse the two. What is this right here? So under the root file system, I have a directory called root. That's the user, the home folder for the user account called root. So if root created any files and wanted to save them, they would be saved in that folder. So that's root's home folder. This is root. The root user account is the administrator account. Unlike Windows, we only have one administrator account. When I could have home directories for all my users under home. So if I had a user account called bfairs, their home directory would be stored under home. If I had a user account called student, their home directory would be stored under home. And I could make that a network share. So when I sign in as bfairs here, all the files that I've saved in my home directory will be available to me. If I log off here and sign in here, I want to mount that network share and access the same files. So the home directory could be a network share. But what happens if the network was down? We wouldn't be able to access those files. We don't have that offline concept. So we can never have root's home folder be in any partition other than the root. Home could be another partition. Home could be a network share. So we can't put the root home folder there. So the root's home folder will always be under root on the same partition. If root can't sign in, you're dead in the water. Back when I took the Red Hat test the first time, 10 years ago, whatever it was, they actually, you have a section of the test called break fix. The computer is broken and you can't boot to it. So you have to fix it before you can even boot into the thing. If you can't, they kill the test and you can't go on. They don't even show you the rest of the questions. You have to fix it before you can move on. And they basically filled the hard disk with a dummy file. And you have to sign in, do some sort of like recovery, find that file, delete it, and at that point, you can sign in as root. So no one can sign in except for root in that type of scenario. 5% of the hard disk will always be reserved for root. So you can't fill 100% of the hard disk. When you hit 95%, it's going to save 5% of your hard disk just for the root account. Those are important things to remember. Root's home folder always has to be under root, and at least 5% of the hard disk has to be available for the root user to sign in. It won't allow you to override that 5%. It's just like hard coded into the kernel. Okay, so we're going to talk about this bin directory. Actually, I'm going to pull it up on, I can do Wikipedia. I can pull up, and that will not cause a problem. Okay, Linux has a standard. And people in the Linux community get together and they decide what is the file system standard. And they it's kind of like, for you to be considered a Linux distribution, you have to follow that standard. So if I go into an Ubuntu box, I know what directories to expect. If I go into a Red Hat box, I know what directories to expect.
So we have the root of the file system. Then we have a directory called bin. That is the binary programs that normal users would execute. On our box, it's actually a link, and I'll go there. The next directory that you should expect is the boot directory. That's going to be on its own partition, and it's going to hold your kernel and any bootloading files that you have. The next directory is the dev directory. The dev directory is going to hold all your device drivers. We call them modules in Linux. So all your device drivers for everything was going to be in the dev directory. Then you have the etc directory, which stands for etc. That's going to be all your configuration files. In Windows, we have something called the registry. It's like a database of all settings for applications. In Linux, you don't do that. What you do is you install the application where you want to install it. The executable part of your application has to be either in bin or create a link in bin so someone can execute it. Because by default, when you execute a program, that's where it looks. It looks in bin. Remember how I told you I can have a program in multiple locations? I might have it in bin, I might have it in SBin. When I type the which command, it's going to tell me which one I'll execute. And let me show you why. Incidentally, the same applies to Windows. So if I go and do echo $path, that's my path variable. So when I try to execute a command, it's going to look in one of these directories for that command. So I might have the command here, I might have the command here, I might have the command here. So it'll tell me which one I'll execute first. If I have a command here and a command here, and it's the same command, it's going to execute this one first. Windows has the same concept, but Linux does not execute files in your own directory by default. Windows does. So this is where your program is going to be located. So if you install a program or you write a program, you're going to install a program wherever you want, maybe the opt directory. You want to link your executable in the bin directory because by default, that's where users execute programs from. And then you go and put your configuration file in the etc directory. That's where users expect the configuration file to be. Windows, we have a registry. For Linux, we have the etc directory. We have another directory called opt for optional software. Some people just put it in bin, other people put it in opt. If you put your software in opt, the configuration files should be under etc. But no one does that, they just put them under X. This is what you should be, this is what you should do. This directory, I've never played with before, but it's for, I guess, catalog files, for configuration catalog files for software that you're currently running. The CTS1111C directory, we have a piece of software called X. That is our graphic interface, or was back in the day. We're actually moving away from X and we're going to Wayland, W-A-Y-L-A-N-D. But when it was a command line only interface, a company came up with a piece of software for a graphic interface that built the menus and the little X boxes to close the windows and things like that, and they called it X. And it was open source, meaning anyone could do development and stuff like that. then the people who developed X said, well, on version 12, let's not make it free. Let's force people to pay for it, because we're not getting paid. Because that's what open source software is. A lot of it's just freely created software. So a community said, let's fork the X project and create X11. Because version 11 was the license for version 11 was still open source. So you had the paid version, X, which went to 12 and 13 and so on. No one bought it, because the free community continued upgrading this on version 11. So they just called it X11. So it's just the company X is no longer even around anymore, but version 11 is what we still continue developing. If your software has any XML files, those should be stored in XML. Home directory, that's under root. Let me explain what this is. Here's my root directory. Inside the root directory, I have a folder called Etsy. In the folder called Etsy, I have a folder called opt. So these are just folders. So under root, I have a folder called home. Under home, I would have a folder for every user account that I have, and that's where they would store their files. This could be a network share. This could be on a different partition. I would still have the folder under root though. Lib directory is for library files for your binary. So if you have one program that builds on another program, someone writes a library and then you write a program that uses that library, the library files are going to be stored under lib or lib64. Lib is 32-bit programs. Lib64 is lib64 is 64-bit programs versus 32-bit programs. Okay, this is where things get messy. The mount directory was a directory that allowed you to temporarily mount other things to. Could be another partition, could be a network share. And everyone has access to it. And that's what we used for years. But then when we started getting thumb drives and CD-ROMs, when one user would mount it, everyone would have access to it. And they said, well, that's really not for a temporary file system. We really need to create our own directory for thumb drives and CD-ROMs. So we're going to create that media directory. When you put in a CD-ROM or a thumb drive, it got mounted to media. But again, everyone still had access to it. So they came up with another way of doing it, and they created this run directory. So if you put in a thumb drive, it would mount that under the run directory, under your user account, so only you had access to that thumb drive, not everyone in the system. But when they make a change like that, they can't get rid of the old change. It kind of hangs out there. So we still have media, we still have mount, and now we have run. So some software might use media, some software might use mount, some software might use run. It all depends on the software that you use. So you have all these things that have been lingering over time that never gets updated, because there might be some old piece of software that still uses it. The opt directory is really a directory for optional software. A lot of people don't use it. The only one that really uses it is Oracle for the database software and for the Java software. Most other companies just use the bin directory. The proc directory is a pseudo file system. When you boot up your machine, the kernel creates a directory called proc. It's just in memory. And it's all the kernel parameters. So you can't go in there and edit the files or anything like that. You can just put a 1 or a 0 into a certain file to turn on or off a feature in your kernel. So it's a pseudo file system. It stands for processor. That's what's created when you boot up your machine. Anything your kernel knows about, it's going to be stored in the proc directory. The root folder is the home directory for the root user account and has to be
under the same partition.
The SBIN is the directory for the super user. We call root the super user. So any administrative commands are going to be under SBIN. You don't want normal users to be able to execute. The bin directory is programmed for the normal user. The SBIN directory is programmed for the root user. The server directory is data for services. Back in the day, if a service had a data that they needed to dynamically create, initially they would put it under the var directory for variable data. Now they created their own directory just for those services called server. Some programs use it. If it's an old program, it's probably still using the var directory. The var directory is also where we keep our log files. Again, that's variable data. The sys directory is information about device drivers or any, like, well, it's not to be read by humans, but it's going to be by the device driver. Modern network cards, the firmware is not built onto the actual network card. It becomes part of the driver. Because if the firmware was built into the network card itself, when they needed to update it, they would have to give you a new network card. So what they did was, they decided that we are going to create a little memory chip on the network card. So when you boot up the machine, it's going to take the firmware off of the computer and copy it to the network card on that little memory. So that firmware is no longer stored on the network card, it's actually stored on your computer. That's going to be in the sys directory, stuff like that.
Some people put it in a firmware directory. That's another thing. Temp directory is like a free-for-all. Anyone can write to it. So if you open up Mozilla and you open up a web page, it's going to cache that web page. It's going to be stored in the temp directory. So this is where things get really ugly. Okay. Back in the day, the bin directory was for programs installed locally on your machine. And the SBIN directory was for programs installed locally on the machine, which wasn't a lot because it was really expensive to have hard disks on each individual machine, so they were relatively small. So what a lot of companies did was create one server, install all the programs on that server, then mount that onto each machine as a network share under user. So under the user directory, you would have software installed from the network. So you only have to install it in one location on the network server. So if you install a program, let's just say IPconfig, for lack of a better program. You install it on the server, you can mount it on all the workstations, then all the workstations will have access to that program. So bin and SBIN were for local programs. And user was for programs installed on the network. So under user, you had a bin directory, you had a lib directory, you have a lib64 directory. You had I'll go into that. You had an SBIN directory. Over time, it got cheaper, hard disk got cheaper, so they started installing everything locally. So people started installing programs under bin. Okay? So then people got confused. They're saying, are these local or these on the network? Well, let's do this. Let's create a subfolder under user called local, and create another one called share. So under share, you would have network files. Under local, you would have local files. Okay, well, isn't that what the bin directory was there for the first place?
Correct.
So under user, you have a bin. Under local, you have a bin. You have an S bin. You have a lib. You have a lib64. You have an etc directory. Then under user itself, you have a bin directory. You have a lib. You have a lib64. You have an S bin directory. You have a sources directory. It got confused real quick. Then people started putting stuff under share. It says, well, it's stupid for us to create a bin directory. We'll just put everything directly under there. So it's very confused right now. So when you install a program, you can choose to install it under user bin or under user local bin, or you can just put it under share directly under user share, or you can just put it under bin or S bin. You know, it's just like all kind of confused. Red Hat tried to alleviate that problem by saying, we're not going to create a bin directory, but we have to put it there to be backwards compatible with old programs. So if anyone goes into bin, and I'm going to show you something right here, I'm going to do a list long root. Where does bin really point to? User bin. So if you save anything under bin, it's going to be under user bin. So if you put anything under lib, it's going to be under user lib. If you put anything under S bin, not all distros do this, but they're trying to eliminate 35 different locations. And they're going to do that by using what? What does that first character, L, stand for? Link. D stands for directory, L stands for link. So when you go into that directory, it really takes you to that directory. Just the link. So that doesn't really exist anymore. It's just a shortcut. So they're trying to clear it up. So user directory over time has really changed quite a bit, but it's a secondary hierarchy. Initially, it was designed as multi-user, meaning it was mounted from a network drive. Okay, guys, a few other directories you have to go over. var directory, variable data. What's under var log? Are log files. Runtime data for applications used to be under var run. We now put that under server. If there was variable data for software under op, it was stored here. If you set this box up as an email server, the email boxes were stored here. If application has some sort of cache data, it would be here, or var run, or server directory, depending on where they put it. Spool directory is if you had print queues.
Right.
The spool mail directory used to be the mailbox. That's being deprecated. They're actually deprecating that. That's a good thing. They're actually saying, in the future, we're going to stop making this directory. They put it under here. Guys, your temp directory is deleted every time you reboot. The root, the / temp directory is deleted before root. If you need to create temporary files that needs to be persistent after reboot, you store them under var temp. Because this directory is not deleted like the regular temp directory is between reboots. So that's the difference between that temp directory and this temp directory. You reboot, everything is wiped. You reboot here, everything is saved. Not everyone has access to write to that var temp.
If for an enterprise environment, right, that uses enterprise environment and uses Linux, do you think all the directors are being used, or?
They have to be there, because that, if they're not there, then they're not satisfying the standard created by, that's what they're saying. You're gonna advertise that you're gonna be file system hierarchy standard compliant, meaning those directories are there, and they satisfy it by doing links. Red Hat doesn't use the bin directory anymore. But to be compliant with the file system in the industry, they create a link so it looks like it's compliant. So if you go into the bin directory, it really takes you to another directory. So they will be there. But a distro doesn't write the software. A distro doesn't write the software like the DHCP server. Someone else writes it. All a distro does, it takes all the software out in the industry, puts it together on a nice friendly install. So the DHCP software that is running on Ubuntu is probably the same exact software that's running on Red Hat. They might just decide to implement it a little different, maybe put it in a different directory or something like that, but it's really the same software. So yes, all directories will have these available, all Linux distros will have these available, and you'd be surprised, even your phone has it available. If you have an iPhone, it's a Unix box, it follows a lot of the Linux standards. So these will all be there, and if you look at our system right now, you'll be able to see, like, if we went into the var directory, I have log, I have mail, I have spool, mail again. You see what I'm saying? They're trying to deprecate spool, mail, but Red Hat doesn't want it. Red Hat wants the original location. So when you go into mail, guess where it takes you? Var spool. It looks like we're in var mail, but we're really not. And again, they do that with links. So I'm going to do a list long var, and I can see mail really points to spool mail, even though they're depreciated it, it's being deprecated, it's still going to be being used by Red Hat. Okay, so guys, let's do another break, 5 minutes here before you go. You start your next break. I'm going to click on you software. Type in student on that. Reinstall. Type in R CTS1111C space hyphen space space Faris FARIS tab 658695 run. Click OK. Now reboot into that server. It's going to be a couple reboots.
Okay.
Yes, is that you? What's up? What's up, man? 5-minute break. You're trying to log into your Xbox? speakerphone and I can tell you real quick. That's right, it's not. Am I on speakerphone or am I on speakerphone? No, you just go through the drop down and from the top where it's green. I'm on speakerphone. Take me on speakerphone. Take me on speakerphone. Oh, okay, that's what it's called. Okay. It's 1313. That's the exclamation point. That's the same password. It's the same one, but with the exclamation point at the end, remember? That should be Meter 224 then. Yeah, that's the one. He's just trying to log in on what, the one in your bedroom? Oh, he's not already set up back there? Or did he log out and needs to get back in? Alright, either way. You know how to log in or sign in. You know how to sign in. Yeah. Okay, well that's it. I don't know how often that happens. It's up when you're looking. And when, how soon.
I'm going to do attendance now. Emmanuel's here, Christopher's here, Christopher Blum, Jorge,
Yeah.
Sean,
Here.
Adrian is here, Jefferson
Here.
is here, Michelle is here, Phila.
Here.
Okay. Mark, Will is here, Yvette is here, Christopher Minter,
That's me.
Josue is here. John Navarro. Jessica Ortega is here. Andres.
Here.
Osvaldo. Belinda is here. Juan is here. Daniel Stevenson.
Yeah.
Okay. Jordan Stewart. Okay. Javenas.
Here.
Yeah. Jorge Vidal is here. Sydney is here. Okay. Guys, I'm going to sign back in. Look, if I go here, CD, Etsy, it will, and I do PWD, that'll tell me what directory I'm here. What directory I'm in. I can do CD, var log. That'll tell me what directory I'm in. CD stands for change directory. PWD stands for present working directory or print working directory. Just lets you know what directory you're in. So I'm going to do a list. No, actually I'm going to do a list-A, AL. List-AL. If I go to the very top of the list, I see these directories. Same as Windows. What does the two dots represent?
The directory after.
The parent directory. So,
PWD, in this case, I'm in var log.
so two dots would represent var. What does the one dot represent?
Log. The one after.
My current directory. This is the same as Windows.
So if I did CD dot, where would that take me? My current directory. It does absolutely nothing.
The CD dot dot will take you up one.
CD dot dot will take me up one. So I'm going to go CD var log. So what would this do?
Take you bars.
Then,
Log, back.
so I'll go up one directory, then back in. It does absolutely nothing.
But I'm trying to stress a point.
You know,
This and this do the same exact thing.
this is absolute. This is relative. This is relative because it'll only work if I'm in the log folder.
Right.
This is absolute. This will work no matter where I'm at.
So I have a directory called Samba right here. Inside of this directory, I have another directory called Samba. I can do this.
That will take me to the Samba directory.
Using the relative path. Again, that only works because I'm in var log.
If I wanted to specify the absolute directory,
This will work no matter where I'm at. CD, var, log, Samba. So this is the absolute path. This is the relative path. This is relative to where I'm currently at. So, CD tilde will take me to my home directory, whoever I am. I'm signing in as root, so it'll take me to my home folder. Guys, remember this file? Etsy password. I'm going to look only for a line that has root in it. Cat Etsy password, grep for the word root. Only show me lines that have the word root in it. So how does it know where my home folder is? And the Etsy password file tells me, there's where your home folder is. If I was a student, it would take me to student's home folder. That's how it knows where your home folder is at. If I'm in var log and I do cd alone with no tilde or anything, again, it would take me to my home folder.
So CD without any specification is home.
Right.
The reason why we have the tilde is if you're writing a script and you want to say something in the user's home folder, you can tell them, you can put that tilde in the script and refer to someone's home folder without having to know who that user is. Okay? But normally if you want to go to your home folder, the quickest way to do it is just type CD. Again, because I'm lazy. That's the easiest way to get to something.
I'm going to create something, and you just watch. BI. So I just created a script right there. So what's the purpose of, we understand what 2 dots is. It takes you to the parent directory. What's the purpose of the 1 dot? Why do we need that 1 dot? So I can specify the file in my current directory. I don't want to have to type this every single time. This would be too much. Sorry. So that would be too much to type every single time. So I can specify and it's a lot easier to type the 1 dot. That's the purpose of the 1 dot. So you can specify that whatever you want to do to a file is in your current directory. Now, if I echo $path, my home directory, which is root, it will never look for a file in my home directory. That's not where it looks for files to execute. So if I want to execute a file that's in my home directory, root, I have to hard code it in there saying the file is local. It's in your current directory. By default, it doesn't look in your home directory. So if I want to execute a file that's in my home directory, I have to specify dot. This would work as well. What does tilde mean? My home directory. It's just,
So if you want to execute a directory, a file, or refer to a file that's in your current directory, use the single dot. That's the purpose of the single dot, your current directory. The 2 dots is your parent directory. If something's in your root folder, your home folder, you can use the tilde. Most of this stuff, except for the tilde,
you know something? I don't even know if that is true anymore. Let me see something. Windows will accept it now too. You know, so a lot of the stuff that works in Linux works in Windows as well. Okay, so let's see where we're at. That was just a little bit about how to navigate the file system. Okay, I'm in my home directory. Everyone be in your home directory. Touch new file.txt. List long. If I don't specify a directory to list, it lists my current directory. So I just created this file right here. If I don't want to see all the files in the directory, I just want to see that one file, I can do list long grep for new file. And it will only show me lines that have the word new file in it. If you're dealing with a directory that has a bunch of entries in there, you can use the grep command to filter out only the lines that you want to see.
Why does yours say newfile.txt, but I ran the same command and mine doesn't say? Oh, it's just not in red. Why is yours in red and mine?
Because I did list long, it showed me everything. But when I do this and I grep for new file,
Oh,
it's showing me the thing I'm grepping for in red. Yep, straight up the type character.
oh.
The pipe command you can use as many times as you want, like one after another, after another, after another.
Or, right?
No, it means the output of the first command becomes the input for the second command. You pipe to another command. You use to redirect to a file. We'll get into that. So you pipe from one command to another command. So what did the touch command do? Okay, so I'm going to touch new file.txt. Now what did it do?
Look at the time stamp.
So you touched it.
So touching it, the purpose of the touch command is to update the access time.
Show the last time that it was accessed?
Right. If the file doesn't exist, it will create it, then update the access time.
So it creates stuff too.
If it doesn't exist, it will create it first and then update the access time. If it exists, it will just update the access time. So most of the time people use touch just to create a blank file. Okay. It's really not the purpose of the touch command. It's really designed to update the access time. If the file doesn't exist, it creates it first. How big is that file?
0.
0 bytes.
I thought it was automatically. Like once you go into the file, it'll update automatically for the time.
It will, but what if I just want to update the time? A lot of times, if a file is stale, like you install a program the first time, the programmer created a bunch of directories, but the timestamp is all wrong. So what I can do is, what is this going to do? Touch asterisk.
Oh, touch all. You touch all.
That update the access time on all the files in that directory. So if you just install a program that's not working because the access time and the files are wrong or stale, I can do this.
I want to look at help. Guys, if it's the current year, it doesn't show the year. So touch Guys, I don't remember these commands. Honestly, it's been so long that I've seen so many different OSs, I don't remember the commands. So, I'm going to do T. So, touch, (1851) November 30th at 11:59 p.m. New file. List long grep for new file.
So you can modify it, you can actually change the last number's access.
Right.
Yeah, but you can
So
lock
the
that, though.
timestamp, you know, they talk about forensics and stuff. Oh, we looked at the timestamp of the file. Anyone can change it.
You can lock
So you
it,
can change it.
right?
I'm sorry?
You can lock that.
Nope.
No? Sure.
So timestamp is wrong. It's irrelevant. I can do whatever time I want. Obviously, I didn't go back to 1851 and create this file.
Exactly. You can kill it with graphical.
Okay.
But only root people can do this, right? Or no users?
Touch test file.txt. Touch T 18. Sorry, numlock. ST 1880 November 15th at 2:30. Who am I? So no, as long as I have permission to the file, I can do it. Okay. So let's say I wanted to create a file in the var log directory. So when I touch this file up here, did I use a relative path or an absolute path? Relative. It's going to create that file in my current folder. If I don't specify, it'll create it in my current folder. Well, let's say I wanted to create it in the students folder. So I could say touch, in the home directory, there's a student directory. In the student directory, there's a desktop directory. Sorry, desktop directory. Guys, I hit tab. That's why that showed up. I hit tab. So I can do another file.txt. Give me 1 second. I don't know how.
Does it minimize maybe?
Where is that at?
Blue to the right?
No, that's the virtual machine.
What are you trying to do?
Get to my desktop.
Oh, the thing next to the minimize maybe, just make it smaller?
No, that's for the virtual machine.
Still for the virtual machine.
No, just click the bar at the top twice. The blank bar? Right. No, the blank one. Yeah, right there. No?
Okay, there. Okay, so, sorry, here's my thing I was trying to do. If I go into computer, home, student, in the desktop, there's the file I just created. Okay, so this is a relative path. It's going to create it in my current directory. And this is the absolute path. This will work no matter where I'm at. Okay, let's do this. Make dir test directory. List long. So I just made a new directory.
Again, I'm given the relative type. What if I wanted you to make a public directory inside of the mount directory? What are ways I can do it?
You can go to, you make directly folder.
I could do this. CD into mount and make dir public. I'm going to go back to my home folder. Okay, yeah, it's there. List long MNT. There's a public directory. Or I could have done this. Make dir MNT public. I won't do it now because it's already there.
So I can go in the directory, then use the relative path to make it, or I can stay where I'm at and use the absolute path. I want to make dir 3 in the MMT. Right now, inside of MMT, I just have a public. So I want to, inside of mount, inside a directory called dir1, inside a directory called dir2, I want to create a directory called dir3. The problem is, this is what I want to create. This doesn't exist, and this doesn't exist.
So I can do make dir -p mount dir1 dir2 dir3.
I'll explain what this is.
For the types?
P for parent directory.
Parent.
If you're missing any parent directory, automatically create them. So I try to create dir3 and it says, wait, I was missing dir2. That's the parent directory, so I'll create it. dir2 says, wait, I can't be created because I'm missing dir1. I'll create it. And what does the tree command do? Shows everything under there. So this, I had a public folder, now I have dir1, dir2, and dir3, because I did the -p. Otherwise, I would have had to do make dir mnt dir1, then make dir mmt dir1 dir2, then make directory mnt dir1 dir2 dir3. This is lazy. This is the way to go.
What time does this class officially end?
45 or something?
Yeah,
11:45. Oh, okay. Okay, we'll at least be able to get through this. I won't be able to start chapter 4, but that's fine. So, I'm in my directory, my home directory, list long, I'm going to delete this. RM new file .txt.
Stands for remove.
Let's see which remove command I ran. When I run RM, which command do I run? I have two versions of an alias is like another shortcut. I can take a big long command and make it short. When I normally run RM, it deletes a file, no questions asked. Just deletes it. There's a command called, there's a switch on there called -I, interactive, meaning prompt you before you delete it. So just to be safe, they don't want you to run RM directly. They want you to remove RM interactively and prompt you to delete the file. So I'm going to touch that file again, recreate it. So RM-force will no longer prompt me, so I can override the -I behavior.
Dash or FORC is the same.
Bang T. What is bang T going to do? Right, it's going to run the last command starting with T. So RM-force new file. If you're going to use the full spelling, it's --. Way too much typing. You know. So bang T. Do not run this command. I'm gonna do this. RM dir test directory. No, you can run this command. That's fine to run this one. There's a command that I'm not. So what does that do?
Goes for the right directory.
If the directory is empty.
RM dir MMT dir 1.
I can't delete this because it has this in it.
There is no force command. RM dir -f MMT dir 1 won't work.
We'll have to do one by one.
RM dash recursive force. Sorry, that worked, but I meant to do that.
So that will allow you, normally RM is designed to delete a file. RMDIR allows you to delete an empty directory. But if you want to delete a directory with all its content, you do RM-recursive, meaning go down through the folders, force, and that will delete everything. Now,
remember, F, I'm going to touch this file again. I could do user bin remove and not be prompted to delete the file because the default behaviors don't prompt you. If I do RM with force, it overrides the -I behavior. So what would this do? Do not run this.
Delete the root.
no questions asked.
Just deletes the root.
It just deletes everything. It's all gone, recursive. They're not in a few seconds, not
you know, it doesn't take them a while, it just wipes everything out. So you need to be careful and very conscious of where you're at. So if I did this right now, so let's go into, I'm going to do make dir, test 1, test 2, test 3. I'm going to make all those directories. And cd into test 1, test 2. And if I did rm-rf on my current directory, oh no, it's confused. It's not going to work. Well, what I was trying to prove is, if you were in the root directory and you did an rm command to your current directory, it doesn't like that beginning dot. The remove command doesn't like it. You could delete everything and make a mistake. So you need to be very conscious of where you're at when you're using that recursive force command, because at that point you could wipe out a lot of stuff. Okay, guys, we are done with chapter 3. So that's where we're going to end. I'm not going to start another chapter right now. That's it for today. Get on LinkedIn Learning. Start watching those videos. And start practicing. How many people weren't here last time? Okay. You got to email me. I'm going to send you a link. No, actually, we're going to do that right now. Everyone else can go. I want to fix them up with ACE-IT so they have a place to practice. Yes?
Which one do I take?
There.
Alright, so
No, she won't go up. Right.
awesome.
Okay, and just use you have a bit trunk line. I don't know if it's going to work here.
No, yeah, I'm just gonna download it, and run it somewhere. Thanks, Professor.
You're welcome.
I have a
I'll send you this.
I opened the Linux on here, it's asking me for the password. Where would the password be located? Because I thought I'd need the password to log into the actual computer.
You're trying to get SU. You can't. So I'm going to show you the instructions. SU, there, it's not set. Just keep hitting here. Okay, good. Okay, now
I
try
haven't
it.
done it yet, so.
Sudo.
Hopefully I can do it too,
Sudo, with the O at the end. Super user do space bash. Sorry, no, I'm sorry, I'm describing what that command is.
Oh.
Super user do, type bash. So as your normal user account, you're trying to execute a bash shell. Now set the password. Do sorry, we're going to do the password command for the root user account. Hit enter. Now you use whatever password you want to use. Yes, I'm assuming to get in on that will be in the chat. There's also you can chat right here with them, or you can give them a call. Okay.
Okay, so now that that's...
Now type exit. Okay, now type SU space hyphen enter. Now you set your password. Oh, no, I see it. SU.
I just said it.
No, that's okay, that's right. There's an export command that's wrong, don't worry about it, but now you're signed in.
Oh, yeah, and then do the...
So you can either get in now with that or with that.
Okay.
Because remember, this is a Debian-based derivative, and they don't want you to sign in as root.
You said there was a proper way to shut out our, terminal so that we don't have problems logging in next time?
No, there's a proper way to shut down your real machine, so I want you to shut down your real machine.
Just shut it down completely.
Not Linux, not the Linux server.
Okay, so,
If you weren't here last week, open up a browser and go to www.aceitlab.com.
I'm sorry, go to www.aceit.
aceitlab.com. You have to type the www.
LSIT.com.
Right.
That's it. Okay.
Okay. Now,
Instruction, he says.
sign in with, when did you, everyone registered for the course a while ago, right? Sign in with your student email address and that password.
Oh.
you already did this.
Yeah, just refresh it. Okay. I'm gonna open up a incognito terminal so I can show you what it looks like.
You're still recording?
Yeah. I'm gonna stop this.
See what?